Eyer has a multiple baseline approach. This means that we form a main baseline for the behavior that was observed most frequently in the past, and a secondary baseline or secondary baselines for behaviors that are deviations from the main behavior that is observed in the past but still were frequent enough. So now I want to focus on the concept of secondary baseline and how these baselines are formed. But before I go into that, I want to remind that Eyer is an unsupervised learning tool, so it learns from unlabeled data. So when we get the data from our clients, we learn from them as they are, and we have no labels that can tell us if a data point is anomalous or not. So, since secondary baselines are defined as baselines describing deviations from the main behavior, they could be formed from data that are anomalous, that contain anomalies, because anomalies are deviation from the main behavior. For describing the situation a bit more in detail, let me use this Grafana dashboard and focus on two concrete examples in which I know if there were anomalies or not. So this first example is a metric that historically goes up and down and switches between one behavior up here and another behavior up here. So for example, if you go in the last 6 hours, this is the behavior that was in the last 6 hours that is considered completely normal. This red baseline is the main baseline. And at the same time, we see the secondary baseline that is up here. That is where the secondary behavior usually appears. But if we go back in few days, we see that actually the situation was still the same, still with the metric in this lower behavior, but at the time the upper behavior was considered a bit more frequent still. So this was the behavior was in the secondary baseline. If you go even a bit more back in time, we see that the situation was instead that, like, at the time the metric was in the upper baseline, and the upper baseline was the main baseline at that time, and yes, it was still completely normal. So with this type of metrics, we see that, like, the metric is usually contained in one of the two baselines, and the main baseline and the secondary baseline might interchange based on which behavior was the most frequent, was observed most frequently. Okay, as I said, this was an example of a metric that didn't have any anomaly, but now I want to show you the example of a metric that actually had an anomaly, and is this metric that is usually it goes a bit like this, is in this area, but at a certain point started to grow, and went up, and this is an anomaly. So if we look at the main corridor, you see the usual behavior is included in the main corridor, even if now here it started to grow again. But after a while, this anomaly that lasted quite long, you see, so in several days, started to form a secondary corridor. So now there's a secondary corridor up here. So this is why when we detect the anomalies, or we do our anomaly detection, we say that if a data point is in the main corridor, the chance that this corresponds to an anomalous behavior is extremely low. So this basically main corridor is the anomaly-free corridor. The secondary corridor, we cannot guarantee that is anomaly-free. So we assign a bit of severity to the data points that are falling in this secondary corridor. And again, this might correspond also to perfectly normal behavior. So a data point that is in the secondary baseline, even if it has a bit of severity, has still a lower severity and a lower chance of being an anomaly than a data point that is falling outside any of the baseline. So when we build an alert and we build a anomaly alert and we observe deviations, we take into account all these different situations in the main baseline, in the secondary baseline, outside all the baselines. And in the next chapter, we are going to talk a bit more on how we form this alert and these anomalies, and now we combine all this information to deliver anomaly detection to the user.